Okay, so today we're going to look at compound inequalities. So basically what we're doing is we're taking two of the simple inequalities that we worked with before and we're combining them together to make one big inequality that's either joined with the word and or the word or. Okay, and obviously the word and, or it says up at the top, an and is called a conjunction and an or is called a disjunction. Okay, not super important that you know the words conjunction and disjunction, but it's probably good that you're familiar with them, okay? All right, so up in the top box, it gives us a couple different problems to look at. It says all numbers from 3 to 8 inclusive. So looking, and the main thing that I really care about is looking from the inequality to the graph, okay? You already know how to solve the inequalities. Now we need to know how to graph. That's the big important part. There's one other little thing that we need to look at, but nothing too major. All right, so in order to be able to understand the differences between an and an or problem, I want you to do something for me, okay? So I need you to stand if you are a male. Okay, go ahead and sit down. And now I need you to stand if you have shorts on. So everybody stand up if you have shorts on. Okay, go ahead and sit back down. Now listen carefully to this. I need you to stand if you are a male and you have shorts on. So what is the requirement of standing right now?
You're a
guy and you have shorts on, right? So why are there some guys sitting down? Okay, they don't have shorts on. Why are there some girls with shorts sitting down? Because they're not guys, right? So in order to be part of an and case, you guys can go ahead and sit down. When I say and, okay, when I say and, I'm specifically referring to the answer I'm specifically referring to the group that fits into both categories, right? To stand when you're a guy and you have shorts on, you have to be both a guy and have shorts on. So if I'm saying on my inequality now in the top row, x is bigger than 3 and x is smaller than 8, I'm looking for the numbers to be graphed that fit into both of those categories. So why are these numbers down here not graphed? They're not what? They're not bigger than 3. They are smaller than 8, but they're not bigger than 3. What about the numbers up here? They have to be smaller than 8. So these are bigger than 3, but they're not smaller than 8. So it's important that we look at numbers that are both, right? These numbers in the middle are the numbers that are both bigger than 3 and smaller than 8. Okay, now let's think about an or problem. So I want you to stand up if you're female. Okay, go ahead and sit down. Now I need you to stand up if you have pants on, so long pants on. So stand up if you have long pants on. Okay, go ahead and sit down. Now I need you to stand up if you are a female or you have pants on.
You said if we're wearing pants. You mean long pants? Okay. We're all wearing pants. It's just they're shorts.
What is the requirement of standing right now?
Female or have pants.
So what is the requirement of standing right now? Female or pants, right? Why are there some females sitting down? Are there any females sitting down? Oh, no.
No, because you said
No,
female.
right. So why, if I said female or pants, why are there males standing right now? Because they have long pants on. Why are there some females with shorts on? Because it's female, right? So if I refer to an or problem, now we're taking, you guys can go ahead and sit down. Now we're taking both of those big groups and we're lumping them all together into the big answer, right? So that's the difference between and or. Looking at this or problem, x is smaller than 5 or x is bigger than 10. So essentially on an or problem, I'm taking both of the inequalities and I'm graphing them all on the same number line, right? So these numbers down here are all the numbers smaller than 5. These numbers up here are all the numbers bigger than 10. Why did I not graph the numbers in the middle? What requirements? They don't fall into either of the categories, right? They're neither smaller than 5 nor bigger than 10. Okay? Was it okay to have overlap? Were there any women with long pants standing?
Yeah.
Yeah, of course there were, right? Just because you fit into both categories doesn't mean you're excluded. That means you're kind of doubly included, even though that doesn't really count for anything. Okay, so we kind of understand the difference between an and an or. Okay, let's look at solving and graphing. So go ahead and go to the next page. Well, what's up with number 1? There's no word. It says they end up above the problem, but there's no word in the problem.
Oh, you have 2.
I do have 2 inequalities. There are 2 inequality signs, but it kind of looks like it's all morphed together. When I have a problem like this, it is saying 3x minus 6 has to be bigger than 3, and this same 3x minus 6 has to be smaller than 8. So it just kind of lumps it in the middle, rather than putting a word in. So our first task every time we see a problem like this is going to be to break it apart. And I don't want to see anybody break it in half and say 3 is less than 3x and negative 6 is less than 8. Okay, I don't want to see you do that. The 3x minus 6 part goes with both inequalities. So watch what I do here. So 3 is less than 3x minus 6. There's one inequality. And I'm going to do the other inequality in a different color. So 3x minus 6 is smaller than 8. So there are my 2 inequalities. So go ahead and do that on your paper. So put your little brackets in. Notice the 3x minus 6 goes with both of them. And now let's write it with and in the middle. So I have 3 is less than 3x minus 6. What kind of problem is this again? And 3x minus 6 is less than 8. Right? That entire 3x minus 6 part goes with both inequalities. Everybody see what I did there? Okay. Now that I break it apart, can you solve these 2 inequalities separately? Sure. So let's go ahead and do that. And this is the part we should already know. So I'm going to do this kind of quickly, okay? So I add 6. So I'm just focusing on the left one first. So I have 9 is less than 3x. Divide by 3 on both sides. And I get 3 is less than x. Bring down your and. And now let's solve the other one. So plus 6. I have 3x is less than 14. Divide by 3. And that would give me 4.6. So x is less than 4.6. Repeating. Okay, so I solved those 2 inequalities separately, and here is my inequality answer. Okay, just a quick side note. Occasionally, and I don't expect you guys to be able to write this kind of answer, but occasionally you might see, if it's like a multiple choice or something, you might see the answer written like this. 3 is less than x is less than 4.6. So basically, they take the problem and they smush it back together and take the word and out. Okay? Again, I'm not expecting you guys to write the answer that way. If you do, I'm not going to count it wrong, but I just want you to be aware of that sometimes they will write the answer like that if it's multiple choice or ECA or something. All right, so let's look at the graph now. So on the graph, all I need is the 2 numbers that we used. So 3 and 4.6. So you don't have to go overboard on the graph. Just give me the 2 numbers that we're using. And now let's decide dots. So what kind of dot should I have at 3? Open. Right, based on this inequality right here, that tells me open dot at 3. And then what about at 4.6? That one's also open. Excuse me. All right, now this is where it can get a little tricky. So you're going to have to use something here that doesn't actually mark on your iPad. All right, so don't actually mark on your iPad yet. And let's look here. So I need you to point on your iPad where the first inequality is true. So this first inequality says x is bigger than 3. So point on your graph where x is bigger than 3. Is it just this stuff in the middle? Bigger than 3 is all of this over here, right? So all of this is bigger than 3. And now I need to know what part of this makes the second inequality true. So what part of this is smaller than 4.6? Stuff in the middle, right? So I'm going to shade it. So since the stuff in the middle satisfies both inequalities, and that is what I need for an and problem, I go ahead and shade the stuff in the middle. Here's my disclaimer. Most of the problems that we do that are and problems are shaded like this, where they're shaded in the middle, but not all of them. So please do not fall into the habit of every time you see an and problem just shading in the middle and being done. Okay? So that's my disclaimer. Okay, go ahead and do the try this underneath it. So go ahead and do the try this underneath it together with your partners. Okay, so I need to break it up first. Remember, I take that 3x plus 5 with both pieces. So I have negative 1 is less than 3x plus 5. And 3x plus 5 is less than or equal to 6. I solve my two inequalities separately. So minus 5, I have negative 6 is less than 3x. Divide by 3, and I get negative 2 is less than x. Bring down my and solve the second one. So I have 3x is less than or equal to 1. Divide by 3, and I have x is less than or equal to 1/3, or you can do 0.3 repeating, I don't care. So here's my inequality. Now I need to graph it. Make sure on your number line you get the numbers in the right order, so negative 2 and 1/3. I have an open dot at negative 2 and a closed dot at 1/3. And now I need to work out shading. So put your pin where x is bigger than negative 2. It's all of this. And I need what part of this is also smaller than 1/3, which again is going to be the typical, the middle here. All right, questions there? All right, let's look at OR. OR is by far easier than an and problem. You can see there's already a word in the middle for you, so there's no need to break it apart. All you got to do is solve them separately. So let's go through this pretty quick here. So add 3, 2x is less than 10, divide by 2, x is less than 5. Bring down your OR. And I'll solve your second inequality. Add 4. So again, this is all the stuff you should already know. 4x is greater than or equal to 24. Divide by 4 on both sides. And I get x is greater than or equal to 6. So none of that should be too hard for you. But now let's graph, okay? So again, on the graph, make sure you get your numbers in the right order. 5 and 6. Excuse me. Go ahead and put on your dots just like we did on and. So x is smaller than 5, so that's an open dot. Greater than or equal to 6, so that's a closed dot. And now remember when we did or, we took, I think I said women or long pants. So all of the women stood up and all of the people with long pants stood up. So essentially what I'm doing is I'm taking both of these inequalities and I'm graphing them all together on the same number line. So I graph all of these numbers, so all the numbers less than 5. So that would be down to the left of 5. And I take those and I graph those all with all of these numbers as well. All the numbers that are greater than or equal to 6. So I'm shading over to the right of 6. Again, my disclaimer, most OR problems that we do will look like this with the shading going out from each other. But there's occasionally an OR problem where they come back together or they both go the same direction or something along those lines. Okay? So don't just see OR and shade out. Alright, so let's flip over to the back side. Scroll down for you guys. Go ahead and cross out 1 and 3. I want you to do 2 and 4 together with your partners. So go ahead and do 2 and 4 together with your partners. Okay, guys, so let's look at this. So for 2, I got negative 9 is bigger than x, and x is bigger than 3. Okay, so any questions on how I solved or anything like that? All right, let's look at the graph. So make sure you get them on your number line correctly. Negative 9 and 3. I'm going to have open dots at both. And now let's look at shading. So I want to know where x is smaller than negative 9. So where is x smaller than negative 9? To the left of it, right over here. So what part of this over here is also bigger than 3? Part of this over here is bigger than 3, guys. None of it, right? So what answer is this? You got it. No solution. Okay, it's an and case. That would be like me saying stand up if you have long pants on and shorts on. There was nobody that fits into that category. Okay? So there is no solution. Yes, ma'am.
But I thought, like, if it's less than negative 9, that means to be like negative 8, negative 7, and stuff. So right?
Okay, give me a number that is less than negative 9 and bigger than 3.
Oh, never mind.
Okay, since it's an and case, there are no numbers that fit into both categories. That's why it's a no solution. All right, let's look at the other one. Okay, any issues with my solving? Make sure when you divide by the negative on both sides on the first inequality, you flip the sign. So x is smaller than 7 or x is bigger than 3. Okay, now let's look at the graph. So again, make sure you get them in the right order on the graph. Here's 3, here's 7. I have a closed dot at 3 and an open dot at 7. So remember, since it's an OR problem, I'm taking all of these numbers and grouping them with all of these numbers. So first, I graph all the numbers smaller than 7. So I'm going smaller than 7. Do I have to stop at 3? No, I'm just graphing all the numbers smaller than 7. So I need to keep going all the way. And then with that, I need to graph all of these numbers that are bigger than 3. So I start at 3. I start going to the right because that's bigger. Again, I don't have to stop at 7 because I'm graphing everything bigger than 3. And what happened? A crisscross. What happened to the number line? Everything is shaded. What kind of answer is this? There you go. All real numbers. Okay, so you have to know what and or means. And this is why I tell you, don't just always assume an and problem comes together and an or problem goes out. Because you'll miss these special cases. All right, we have a couple more problems to look at. I'm going to give you like very, very little time. So I need you to do these in about 3 minutes. So 5 and 6. Do both 5 and 6 together with your partners. I'm only going to give you about 3 minutes, so go quick. Okay, so 5. What kind of problem does that look like to you? Looks like an and problem. So I will circle and. At negative 2. Imagine x is the shading. So where is the shading in comparison to x's negative 2? Or sorry, compared to... I'm struggling. Where is the shading in comparison to negative 2? Is it greater or less? Greater. So it's greater. Is it equal to? No, because it's an open dot. Oh, I did the wrong way. I'm on the wrong one there. Greater. Okay. What about 0? Where is the shading in comparison to 0? Less than. And is it equal to? Yes, because this is a closed dot. So now writing my compound inequality, I have x is greater than negative 2 and x is less than or equal to 0. All right. And then 6. Okay, 6. What kind of problem does 6 look like? This is an or problem, right? Going out from each other. What kind of shading do I have in comparison to 9? It's less than, and it's also equal to because of the solid dot. In comparison to 11, I'm shading greater than, and it's not equal to because it's an open dot. So I have x is less than or equal to 9, or x is greater than 11. And there's my inequality. Okay, any questions about that? It's really not difficult to write the inequality from a graph. But you just have to think about it. And or, think about your signs, all that kind of stuff. Okay? No questions? All right.